welcome back for the third session for today. Agentic AI for 6G calls. And we have the same panelists, and also we have the same audience. So during the panel discussion, we also welcome the audience to ask questions or make comments when we have. And before you do that, raise your hand, and then we can recognize you. Thanks. So the first item we are going to discuss is can AI be leveraged to dynamically automate the workflows? Example, the interactions among network entities for executing specific network services. So who would like to start?
The short answer is yes. The long answer is it depends on the complexity of what you're taking on. But certainly you can develop policy-based management systems that you define progressively into finer actions that then cover parts of the workflows in a network. And for those, you can define AI algorithms that do monitoring, analysis, and planning execution to look at the fulfillment, but as well to follow up and as a control loop, look at the assurance of the service. So in individual parts, it can be done. I think the challenge is how to get a whole thing. A network is so big that questions of stability and so forth. Not that any one thing is not working, but the whole thing put together doesn't work. So that's where the challenges are, I think.
Thanks.
So coming from a complete outsider, but my curiosity gets the best of me, I have to ask the question. So not so much whether you can do it. Now with the AI, if I take the hype, it's all powering, all capable. My question is, why would you do it? Is it to save on salaries of network managers? If that doesn't seem to be a big piece of the savings opportunity. So how big, what is the size of the pie, or in whatever KPI you can come up with of doing it, rather than whether you can do it? Assume you can.
I actually know the answer to that, at least for the broadband portion of the network, and that would include the Wi-Fi out to the end devices in the home. So it is used in that portion of the network and has been for at least a decade now. There's a more sophisticated AI, but several companies, including the one I was in charge of, sold products into that space. So pretty much any service provider in the world is using that, at least on the broadband network. I'd be surprised if they're not doing it on a mobile network also, the same type of thing. So there's feature extraction and other things, and they increasingly do want to reduce the number of people who are involved. Also important is dispatches to customer locations to fix problems and so forth, and that is increasingly automated. Of course, not the dispatch, but they try to minimize the number of human interactions. It has enormous value. If you look at the $1 trillion you were talking about earlier, probably about $600 billion of that is operational expense at the service providers, and even making a 5 or 10% reduction is very substantial in terms of their profitability. So I think they all do it. It's just the extent, and I agree with the comment, I'm not sure who made it, on the end-to-end may not be there yet, but that you could expect that to evolve to such a situation. There still are human interventions at various points to make sure that it's okay. So it's happening, and it's based on quality of experience, which is they measure by the feedback from the customers, either call rates, dispatch rates, the happy face, frown face type feedback. All of that stuff goes into the training of the AI for determining whether or not there's a problem. Is it significant? What do they need to do to fix it if they can?
Thanks, Joe.
Yeah, and another example is in the core part of the network, or the internet part. It's still not resilient enough. Just in Canada, we had a major fault a couple of weeks ago that lasted for hours, and the issue here is one that you have monitoring systems for individual routers and network elements, but in fact, faults can still happen in between in the cracks, so-called silent failures. And monitoring overall end-to-end performance is one way of detecting anomalies and faults. And there the impacts are big time in the sense that every hour of outage translates into a lot of money.
Thanks.
Yeah, so we talk about 6G. So since 6G network designs emphasize the customization of deployments, functions, and the resource allocation to satisfy the diverse and stringent requirements of what we call the vertical applications, such as industrial IoT, autonomous vehicles, XR, etc. So with this agentic AI, this customization will evolve into full autonomy, where AI agents not only can configure networks in response to application needs, but also create new applications on demand, driven by user-level descriptions, preference, and requirements. So from the core network perspective, so the focus of agentic AI is more toward network automations and service provisions. So I say a little bit more about the network automation and the service provisioning. So in terms of network automations, network agents can act as autonomous controllers for example, base station or gateways to perform real-time perceptions, reasonings, and network control. And then the network resource reutilization can be achieved for sensing and adapting to changes in the environment, leveraging technologies such as integrate sensing ASAC to dynamically create, deploy, and delete network functions as needed, ideally acting before performance degrades. And then for the service provisioning, service agents should incorporate with user agents to understand user intent regarding the service, and this includes guiding agent-to-agent protocols among user agents, and also the integrating with the SD and NFV to enable goal-oriented communication over the core networks, such as semantic communications. Yeah, thank you.
Thanks, Shuman.
Yes, I just want to add on top of the management and operating, saying that I'll start it. But if you look at the agentic capability, because the input is intent, output is action. That's what this new thing show up. So for all the configuration, deployment, these are manually today, or we have, like vendor as us, have to release software, right, to the operator to run, to set up the network. But if this whole thing can be automated by operator intent as an input, and then AI can take over to deploy, configure, and then of course they will have their own verification in the sandbox test and deploy. This will give me so the networking will come into a new phase. This is a really dynamic and optimized, even could be on the service basis. So that could be the new potential. But the one is coming back is this agentic AI is reliable. The one is, even in the pass through the sandbox test, there won't be fault tolerance and all the other stuff. This is a harder problem because we are in the telecom grade, and it's not best effort, especially when you touch the configuration of the network.
I think a challenging area right now is to determine the extent to which these agentic systems can be made reliable. Part of it has to do with putting guardrails around the actions that are allowed, and part of it has to do with testing it extensively, especially in unforeseen scenarios. I think, be that as it may, for a long time, the high impact type of decisions is going to involve humans in the loop. I think something that involves the entire network, you're not going to let it go without having that.
Yeah, so in with the assumption that the human eventually will in the network to ensure the proper running of the network, but the harder problem here is eventually this AI large language model can somehow tune to the telecom, to the networking context, and then with this generative network concept that can get into this automation of a configuration. It is actually a very good, big technology challenge because essentially the neural network is a statistical machine. So you have to make a large sample of that. The one shot is not reliable, so let's make 10,000 design and test one of them, each one of them, and in the sandbox, and maybe one of them is good. So this is a large area for good research as well, because let's say this is the reliability or even the correctness is still a challenge, and we will see how they can evolve in the AI community. But seems like they are solving the programming problem already.
Yeah, I think, the answer is, I believe eventually it will. That's the yes. And the problem is, which is a research challenge that needs to be done, is not only just interactions between network entities, but also interactions, there's a problems with functions are within one entity. And the more agents we have, there's going to be more, possibly at the moment, it's a research challenge, conflicts between agents, making decisions. And then we need to have a solution to resolve this confliction. Conflict resolution is part of this. So it's a very hard research area that, whether it is radio, or is it network, or is it a core, or is it end-to-end. So I believe we're still not there. I mean, it's 2025, no, it's not there.
So we have more work to do, huh?
More work to do. I think
Yes.
we've got the audience behind us. They can do more work.
So again, as a total outsider, but let me bring the human side to it. I don't know about you guys, but my personal experience when dealing with agents, and here I'm really talking about chatbots, it's been horrible. So we talk about end-to-end experience, and we talk a lot about very optimistic, good-sounding words. I don't know about you, but if I am trying to discuss making an appointment with a specialist, and I get the little window that says you don't want to chat, then of course I want to chat. But then I realize it's a chatbot. So I ask, I want appointment with a certain specialty. Now, it turns out that that particular specialty was not entered into the set of this chatbot. So it responded with some nonsensical answer. And after 3-4 tries, I'm getting upset. And realize I'm talking to a chatbot. my question is not in its library, and it's total nonsense, kill it, die it, I end up hitting it with a cell phone, right? Now, and you tell me that if a piece of the network, say an access point or a base station goes down, and some entity in the network asks for help, that some other agents in the network are going to have in their toolkit the right answer, and they're not just going to answer with nonsensical answers, and then the agent that is asking for help is going to get really mad and upset that is not getting service. I think the two are related. Are you getting satisfaction? Is the solution to the problem really efficient and applicable? John says yes. Is he being too optimistic?
Let me add something here. In the many years ago, we have this GPS lot, and the people rather to have map to do the driving, because when you need the GPS is reloading and make you nervous. But now the GPS is very smart. So probably 5 years or 10 years or 20 years later, the chatbots or agents will be much smarter. At that time, when you look backwards, they say, oh, that is a good direction. That is my trying to think about it in this way. Thanks.
Go ahead.
No, please.
So, yeah, as I said, it's not complete end to end, but typically what happens in these situations where you've got, ridiculous response, they have these tiers of service reporting. So when you call in, that's tier 1, and that's what you're getting. Tier 2, maybe increasingly more AI driven. But there's at least a tier 3, and if you really know somebody important, there's a tier 4 as well, and you will get a human, still, but it has to bubble up, and you have to go through the process of, and you'll have to wait, to get that human, but you will eventually get somebody who knows what they're doing beyond what the AI can do in these systems. But in saving all that people or cost associated with dispatches or so forth to various points in the network, that's a big deal for them to do that. And angry customers for them are a churn risk. And every service, if you look at mergers recently, what one service provider pays for another, it's $1,000 a customer. And that's just look at the price and divide by the number of customers, that's what you'll see. And that churn value of $1,000 is a lot, and it's their profit on the edge. So they really don't want the customer getting so angry that they quit the service, right? So that has a super high value to them, and they do try to reduce the costs. But the whole thing is driven towards the number of angry customers, not zeroing it, but reducing it. So. Thanks, John.
For the information is autonomous networks, which is most of the work is done in TM forum, for example. The idea is to go to zero touch eventually. And at the moment, I think there are some solutions for the core network to set a policy or etc. with the zero touch. I heard, I don't know if it's true, how true it is that China Mobile has deployed this autonomous networking, and they managed, obviously they have a big workforce, they managed to reduce the 5,500 full-time equivalent people in the network operation. So doing end-to-end, I think it's got a few years to go, but it seems to be a promising area for future.
Thanks, Lohan.
Yeah, so just this practical thing is that as far as I know, the few operator already put all their operation manual and all the stuff. This is a big amount of a document in the large language model, so their staff can directly talk to this chat box to talk about this, and this will reduce this like 7-hour downtime. The fault detection, they can reduce down to 10 minutes or so. This is the part that chat box with a simple documentation put into the large language model to shorten their operating, especially the fault diagnosis. Well, of course, this is a human as a tool, but this one is talking the network automation by AI itself. Yeah, so it does somehow helpful. It's not accurate answer, but it's reduce the effort to to search or the information.
I wanted to say another element of the zero-touch management, and when you were talking about sandboxes, is digital twin.
Yeah.
Having a virtual system that attempts to replicate the state of the entire network. And one of the roles it can play in zero-touch management is before you apply a change to the network, you apply it to the sandbox. Yes. And if that passes, then you deploy it. And even then, you deploy it gradually. You don't assume that you've caught everything.
It's good that you mentioned digital twin. I think something in our community is extremely confusing. What is the definition of digital twin? I know it is not written there as part of those questions. Many people refer to simulation or system-level simulation, and instead they call it digital twin, which is not true. So I think the community is responsible to define what digital twin is. I think that's been a term that is extremely misused. Yeah, thank you.
Yeah, thanks, Lohan. How about we move to the next item? And the item is, can AI be used to optimize network performance based on feedback at real time? Example, QoS performance.
I think I just follow up. I think this idea of AI, I think, I know we've talked about reliability, whether it works or not, but I think in general, is it in the next 5 years or by 2030, I think we're going to be hitting this, what I refer to as a self-optimizing network, where perhaps the AI can be used in a continuous way, can analyze maybe the traffic patterns, device densities, application requirement, and then can automatically, somehow in a dynamic way, adjust things like the parameters, like the bandwidth, whatever, or the signal power, in order to make the system work pretty well. And in this context, perhaps one thing that could be very interesting is this idea of generative foundation models, where I believe they can be used to interpret the network state and actually do the stuff that I've just said. So I think, I believe this is going to be feasible. But how reliable, I'm not sure. But I truly believe this is going to happen. It's exactly what you said about the GPS and the maps.
Thanks.
Yeah. So the answer is, I would say, definitely yes, right? So with the introduction of digital twin and network resource virtualization, so a feedback loop can be established, and then this performance through this feedback loop can be recursively improved, right? So I definitely say the answer is yes.
Yeah, so let me add a little history and experience. So self-organizing networks was very, very popular topic even before AI, ML, like maybe 15, 20 years ago. And we did a lot of work on that, even with our common colleague, G. Rittenhouse. And so we had a very exciting new approach to SON networks through advanced simulated annealing and optimizations. And we thought we had done enough simulations. By the way, the name digital twin, I really, it makes me shudder because it's really a pompous word to say simulation. What's inside the digital twin? It's a simulator with a fancy graphical user interface. So garbage in and garbage out. Whatever you put in your simulator is what the digital twin is going to generate. I know it exactly for ray tracing propagation prediction, for instance. You can trust your digital twin, but if at the end, the core, the engine, is a ray tracer, you're not getting any better ray tracer just because you're calling it digital twin. I think in network management, network optimization is the same. What you're saying is you have a simulation of your network, and it's only as good as the engineers that put in the knowledge of the network is the output you're going to get. Long story short, to explain that, we went so far as to deploy the SON into a real market with a real commercial network. And all of our simulations were not quite as realistic. Let's say in modern language, our digital twin was not really a twin, it was just a cousin. And so what happened is that in the real network, you have so many system-level issues going on that while indeed we could reduce the transmit power, and this was supposed to bring all sorts of good things, goodies, because you reduce interference, maybe you can crank up capacity, but at reducing the transmit power, we were actually, unbeknownst to us, and not reproduced with high fidelity in the simulations or the digital cousin, we were increasing the handoff failure. And so the service provider came back and says, yeah, you have something, it's promising, but I cannot give you a passing grade because it's really, I can see here as a trade-off. And you are telling me I can reduce power, maybe I save electric bill, maybe I can increase capacity in the core, but now I'm damaging the edge performance, which determines my user satisfaction, because now I have drop calls, handoff failure. So beware of renaming simulators as digital twins, and remember, they may be just cousins. And overall optimization is a difficult task when you have such a complex networks. And whether AI, ML would have a better chance, it's a very powerful tool in some areas, absolutely. But it's still an open question how many areas this is going to be 100% a win-win situation.
I'd like to clarify that digital twin is not necessarily a simulator. A simulator can be part of that. As an example, take a cellular network, okay? You could be monitoring the number of subscribers to the minute, their QoE in terms of packet loss, uplink, downlink packet loss, round trip time, throughput, okay, at the QoE level. And now you need to tie that to the QoS that's happening at each one of your cell sites. That data can also be collected. So when I talk about state, I'm talking about that set of data. Now then I'm talking about developing Gen AI or whatever models that can work with that state and help you predict what's going to happen, work with that state, tell you when something is wrong, and suggest that changes should be made.
Yeah, so I want to follow up Renato's question. So I have less confident on apply this agentic to the run side because the time scale is not allowed for so far the large model to compute. This is in the hundreds of millisecond level. And if you want a sufficiently large model so that you have those intelligence, then you have to bring up to the half second or even second level. So that's where it's very. I'm not optimistic to go down to the run time scale, but to the network time scale, the programmatic approach is what we should have some kind of design phase, and then you validate on the sandbox, and then you run. It's a design time, and the runtime has to be a little bit separated, so you make sure you have a good quality, because if it is essentially take the advantage of a generative AI. The machine can give you so many candidates. Now you need to pick the most reliable one. So it's a sampling. But it's not sampling like a monkey type, Shakespeare, that type. It's approximately, but you cannot rely on one answer. So you have to sample several times. And the key part is the verification. The moment it's lack of in industry, because these are human design. Now we need to go through. If we're not automation, you need to do some formal verification. Is it mathematically correct or logically correct? So those two has to be ready in or protocol correct. You have to have some kind of a form approval tools, many tools to be ready to do that, and then you have a test verified solution, and then you deploy. And then this is the other thing, the scale of the network. It cannot imagine the entire network be generated by AI so far. Yeah.
So for this question, I can think of the example that a child watch is, for example, watch the old-fashioned TV, analog TV. That's no the smart controller, and the child does not understand the TV principle or how the signal was received, but he can watch the screen and then rotate the antenna and then get the signal better. So that is AI actually. But the child does not know that's AI, how AI works. So they come to the physical layer design of this communication system. I think that the feedback based on the, for example, the capacity, physical layer matrix, or error rate, etc. So then this is the feedback could be used to design the 1-bit beamforming or to design the race antenna for different the systems, and then for this interaction, there's no requirement for the channel feedback, which can avoid use of the pilot. So we can call that model-free communication of model-free physical layer design. That is based on the interaction between the feedback. Okay, this is a good signal or bad signal SNR, and then we can manipulate this is the beamforming design. So this is a kind of the deep reinforcement learning. So that can be applied to the research actually, at least in some papers, and also they lead to the new direction called the model-free signal processing for the wireless systems. Yeah.
Thanks, Wei.
Yeah, just traditionally, when we study the network performance, right? So we have this traffic model, whatever the Poisson, the MMPP, etc., right? And then it goes through the network with certain resource, and then we can observe whatever in terms of QoS performance, delay, loss, etc., right? So now that traffic model, we can use a digital twin, with our digital agent to represent it, right? So the good thing with AI, that digital twin can be updated, recursive, through this feedback loop, right? And that's the reason. So this digital twin based on the feedback performance, based on whatever probably the new collect data, and then to update it, and then proper resource can be allocated provide service, and then you observe performance based on the performance, and then this DOT can be further updated, and then eventually we can. I would say we can achieve the dynamic optimized network performance through this approach. Yeah. And since we talk about this 6G core, and this approach it can be applicable.
Thanks, Schumann.
Okay. Now I just want to say that the future network architecture will go towards more virtualized architecture, separating the software from the underlying hardware. So the performance could be degraded massively compared to bare metal implementation of the network. We were working on this problem, and we say how the virtualized network with the AI, etc., can achieve bare metal performance, sort of. And that was multi-agent reinforcement learning and one-shot training, mix of real data and synthesized data. It just you have to be careful how to synthesize data. We managed to achieve the same performance in real time as the bare metal. So AI was very useful. Without AI, it wouldn't be possible. And most of the quality of service parameters like energy consumption, CPU usage, and delay, latency, delay jitter, everything, we just look at. So it is promising.
Thanks. Rahim, any other additional comments? If not, we will move to the next item. So the next item is beyond providing communications and the computational resources, what additional roles can the network play to support AI?
I think the one that's easy to pick off right away is management and orchestration. Okay, what you can see is the communications and the cloud computing actually converging into a common infrastructure that's distributed and multi-tier. And so then the question is, how do you, manage the infrastructure itself, but how do you deploy services and applications on top of that? How do you ensure that the SLAs of the different applications are met? And that it would be done through the management and orchestration functions over the infrastructure, but it would require sensing, monitoring, and so forth, so you can track the availability of resources and also the level of quality that's being offered. So to me, for sure, management and orchestration is one way to help.
So just to clarify, you mean this is in the data center or across the network?
Across the network, distributed.
I would probably say that sorry, I lost my train of thought here on it. It's the APIs that would be used to access the virtual capabilities that supposedly a virtualized network is going to provide to application providers, many of whom are going to be AI services of different types. So making, as we spoke about this morning, having an API that allows them, the AI, to make use of the network and learn from it in the best way possible to adjust to whatever applications it's providing would hopefully bring a lot of return to both parties, the AI companies and the network providers.
I think the APIs bring up a good point that this infrastructure need not belong to one provider only. Okay, so then there's a role for coordination and brokerage amongst these. But APIs are key to getting access to the resources.
The new opportunity for API, it could be in the context of data that AI community need, and as well the physical sensing data. I think that will be the part to do. For the old API like network function and all the others, for them it's less critical. And actually, it's not easy for them because they need to read some 1,000 pages of telecom specification, and then they understand what is the API for. With that time, they will probably figure out some other easy money making opportunity than dig into very, very difficult communication spec.
Agreed. I meant the former as well, not the network function virtualization stuff, but the APIs that allow the slices to be used for more value in providing a service through that slice.
No, I think the question is, apart from communication and computation resources, what additional roles network can play to support AI? I think we discussed this morning that most of the information we have on internet, 95% of it or whatever, is already been used in developing LLM or ChatGPT. So what is not available for AI so far is network data. And variety of the network data, as well as sensing, I think it would help AI to grow and learn faster and become more accurate.
Yeah, I think related question, I'm not sure whether it belongs in 4, but triggered by what you said, is that there's new applications coming in that include AI elements in various ways, such as LLM agents and so forth. And those have new SLAs. Okay, so they'll need to be supported, but the understanding of exactly how you're going to run the network to meet those SLAs, it's yet to be found because we haven't done it yet.
Yeah, so that is actually an interesting a blank area. Actually, nobody did that study yet. But at the moment there is agent-to-agent communication and the MCP model context protocol are all there. So maybe it's the time that the API will be replaced by agent. So it's not a socket of a format. It has some at least semantic understanding entity more easy than the app developer or even the operator can directly use the natural language to interact. But this quality between the agent communication, this is a big open problem. It is the new problem. Actually, there was a interesting publication from Stanford a month ago. The collaboration with a large amount of agents is because there are a few reasons. One is that everybody do not, with a very high quality precision authentication of their own result, because this is a random machine. And as well, the communication is not precision enough so that they cannot scale up. So far, maybe 5 or 4 agents, and then they start to collapse.
So here I'm going to show my shortcomings as being an outsider, but I think I cannot help it to share with you guys. If you read in the popular literature, let's call it that, although it's surrounded by names of important people, and maybe it's just because media wants to attract clicks and eyeballs, but we recently read a couple of days ago that AI ML was running, and then the operator, the computer scientist, was telling to shut off, and then it is said that the AI ML started to make decisions to protect itself from being shut off. So we are already, what was this, HAL 2001 or whatever. I don't know how much of this is pure media hype. I personally believe that you just plug the cord and that you're done, right? I mean, what are these guys talking about? But we're already into the popular literature talking about ML, AI, fighting with the other version, not to be turned off. So when we have all these agents, what is to stop it from this group of agents creating a federation and a consortium, and maybe because erroneous information, maybe because different answers due to finer precision, that would be the scientific objective answer. Then there is the scientific concept that these guys have an ulterior agenda, and then there is this other set of agents, and they start a war in between them. And how far is this from reality? It's just pure media hype, or based on real explanations like noise in the communication channel, finer precision, could appear to generate these conflicts, but in the end have similar on the surface expressions.
I think in line with that, just a couple of days ago, it was announced that Professor Benjio, who's one of the drivers in AI in Montreal here, had started a venture to fund the development of safe AI.
Yeah.
That's right. Especially to address the issues you're talking about.
Yes, I read. So it's real enough for some luminaries in the field to pay attention to the topic.
But the concern is if it is in the digital world, it will be still okay. But if they come out to the physical world, that's where you need a very absolute verification, authentication, and human has to control that point.
So maybe zero touch there is not the right answer. We need human touch in the loop.
Yeah, any other additional comments? Yeah, the human, the digital area is there's a way the agent can do like federations or resist. But if in the future, if the robots or agents have a control or have a access to the physical layer control, then could be very dangerous to humans.
And how unlikely or likely is that, we're already all super sensitized to the fact that you can get an email saying, oh, this is your bank and we are updating our security. Please log in here and provide your right. My daughter-in-law, she's very busy, traumatic surgery, and after a shift, she's tired. She gets this email, she starts answering, providing information. In 2 seconds, she realizes she's being had. So now drive to home at middle of the night and start canceling all credit card, calling all the, it's disaster, right? Now, what if it's agents doing into other agents inside of a big network?
I think the communication system is a choking point.
I'm more positive and optimistic out of these theories and etc. And I think that the agent representing us in the mobile phone or a device, or is a personal agent, it will know about us, about our work pattern, about tiredness, and etc., and then provide the services as well as protecting, hopefully, us, but from these malicious calls and whatever it is. I think it is not only just the AI in the network, but also what is here that I always say that instead of personal communication that we had until 5G, in future it will be personal services rather than just communication.
So maybe the malicious agent is already science fiction, but I think we are already, if not already happened, it's about to happen, where you have malicious humans portraying themselves as agents or leveraging the capabilities of agents and AI ML to further their criminal cause.
That happens.
Human nature, I guess.
Has been for many, many years.
But if we could help AI to defeat this type of identity theft, I've been a victim of that, and it's terrible. It's not like losing your credit card. It takes months and hundreds of hours on the phone calling to try to save, and you're still going to lose money. In the United States, your case doesn't get taken by the FBI until you've lost $250,000 in this, and the U.S. is estimated to lose $1.8 trillion a year to identity theft. So it is a major, that would balance the budget. And most of it is done internationally from other countries, and they are using AI tools and other things to attack. It's the wealthiest nation on earth by far, so it's getting attacked much more often. So if we could do something to help with that, and if you haven't experienced it yet, you don't want to experience it. It is really bad when it happens. But that would be a great, achievement for mankind to basically cut that in half or by a factor of 4 or 5 would really help everybody.
Nobody can deny that. That's important. If anybody can do so far, we were saying that. I thought the discussion was what AI can effectively damage the society or etc. So now we say that AI, if it can help us to reduce all these long-standing and long-term sort of problems of fraud, etc., that would be good. I remember when it was a hot time about IoT. Everybody was talking about IoT. There were sensors, and people say it can be misused. Sensors, we plant something in the people's mind and in the sweat factories in some part of the world. You can control them remotely and torture them, and etc. We always get all these sort of scenarios discussed and etc. But I think the human race is always the winner. I mean, it's not. But these are the real risks that we need to be aware of, and if we can do something about it, I think that we need, as an engineer or a scientist, that if we can, this is called societal impact of our research, and if you could do that as well as economic impact, that would be fantastic.
But I totally second John's point. If we could answer your point 4, saying that whether it's in the network, maybe most likely most powerful in the network, but maybe it's on the device or a combination of both, if we could very radically reduce identity theft through AI, that would be a fantastic value proposition to the user. I think people would be willing to pay a small amount per month just to have that kind of a security guarantee.
Actually, in many banks, they are trying to do that, but we didn't feel it. Quite often, we still receive some emails like you mentioned, and all these emails never click any buttons, just delete them. Yeah, even don't watch it. Yeah. Any other comments or questions for this item?
I think this is quite the intriguing question. On one hand, that we are scared that if the identity once it's stolen, then the very bad consequence. On the other hand, so actually, if we look into the future, so we envision the meta world in the future, right? And also we want to interact with ourselves in the cyber world. And for example, we delegate our role to the cyber ourselves. For example, they could serve as our agent, AR agent, on behalf of me, and he knows me. He knows all the transaction in the bank. He knows the booking for the flights or the hotel, and he knows my schedule. And probably he will make the transaction or some decision on behalf of me. And he thought, okay, this agent may think, okay, this is for your benefit. But on the other hand, sometimes the virtual world that the server will believe more in that the virtual person than me, in that in the future. So I cannot prove that's true me or mine is true me. So we have the two roles, one physical person, another one is the virtual identity in the world, in the virtual world. In that scenario, it's really hard to distinguish which one is true identity, and all your future cyber behavior will be managed by that virtual person, agent. In that case, it's really dangerous.
So is my avatar likely to be more vulnerable or more strong against identity theft?
Right. That's
Actually, what you are saying is already happening. Actually, when you watch YouTube stuff, the advertisement, all these things, they according to what you read or view, they're trying to populate all the information to you, and also so that's why nowadays they are almost all the sensitive stuff they have dual verification. And also in like Google Cloud, they have all this information. If somebody can hack this information, they can easily mimic you and trying to do something on behalf of you. It's very dangerous. But at the moment, these banks and all this financial and related stuff, they are trying very hard to protect their own interest, because what you lost is their loss, actually. So it is already happening. Thanks. Any other comments for this item?
I just want to reinforce what John's brought up, a very interesting case. Because as you have a theft and then you have to do many things to clean it up, this is a typical workflow. It could be very complicated to go through. So what this agent proposition is that they can take your command and automatically go through this workflow and finish the action. It likes what the Microsoft proposition in the beginning of the year of the agent is that they were saying from 9 a.m. to 5 p.m., average worker has 270 unexpected interrupt of workflow. Some call, some urgent email, this and that, unexpected meeting, and all this. These are all interrupt the normal work efficiency. So that's what they were saying, that okay, we can bundle with an agent to get you more. I think they can do, because they have all the different tools and right. Oh, of course, the last minute PowerPoint modification. Those things can be all become. So the thing is the entire flow, not the chat box conversation, but they can consolidate eventually to a process. That probably be the more value coming to the network and the deployment.
But if I may follow up quickly, so do we have an expectation gap? Because I can see very well, and I share the pain. My identity was stolen like 20 years ago, and that time was kind of trivial. Today, it would be a complete disaster with the variety of accounts and stuff, and trying to find out a human operator to explain what happened. So it's something as simple as booking an appointment with a specialist. In the olden days, you just needed to wait for office hours. You called, you talk to a person, you make your appointment. Now it's like touch and go. Maybe 20% have a web base. In most of them, the web base only means you're submitting an email requesting, and they call you back. Now, some 10% actually have true real-time online. It gives you the time, and you can select. But why don't we have this like 20 years ago already? I mean, all the tools, all the software must be in place to do automatic appointment scheduling. It sounds simple. So if we don't have that, how realistic is that in the next 5 years, I can just instruct my agent to close down all my accounts, bank accounts, savings accounts, 401ks, IRAs, and start them again under my own identity and my owners, and under new numbers to protect for future fraud. So to me, it sounds like science fiction. Sounds like it's going to take a long, long time, unless the application is not the individual user, which the potential for paying is low. If there is some more high value, maybe inside the network where there are trillions of dollars at stake, maybe it'll happen there earlier than at the consumer base where the monies are small. I don't know. What are your thoughts?
I'm not sure. So I think the AI community or the IT community will progress faster. If they have this capability, we should use this for the network management or operation that well.
Yeah, I think money talks, and when the network is moving that kind of dollars amount, it will happen first on network management and the men in the street daily annoyance factor.
Okay, thanks. We probably move to the next slide. Yeah,
Oh,
go
okay.
ahead.
Sorry. Do you want to move to the next question?
Yeah, I'll probably move to the next session item because we are over time for this item. So for the next one is, how can AI embedded within the network infrastructure interact effectively with AI at the application layer? Example, through the use of AI agents.
I think that depends on the OSI layer that we have with the AI. Do we go for these classical OSI layers, that application layer, and then other layers in between all the way to the physical layer, or will it be more flat layer? For example, in semantic communication, the source coding and channel coding, they need to work with each other to reduce the redundancy. And that semantic communication is based on neural networks. And that's possible. I don't understand why this question is important.
What's the name of the lady? Taylor Swift. Okay, let's take a Taylor Swift concert and take the AI on the cellular network or Wi-Fi in the stadium and use it to control how applications at the application layer are treated. There's one example. Another example is take the number of users or unique devices attached to any cell site, okay, and watch the evolution of that over time. It turns out that's highly correlated with the mobility of people in the city, so you can use it for transportation. Okay, so there's funny kind of relationships that lead to that type of interaction.
Mm-hmm. Thanks.
I have a question for our physical layer friends, because I don't know the answer. There's an attempt by NVIDIA to move their GPUs into the RAN, okay? Two justifications or benefits from that. One is obviously that now you can do AI even closer to the user, so it enables applications, lower latency. But the other is that supposedly it can replace all of the processing that's done. So my question is, is that cost effective? And is it true? Does it do all the stuff you need to do?
Okay, you touched a nerve here. And so it's been kind of a crusade of mine for the last 20 years. So it used to be called software-defined radio. It used to be called this or that or that. And it always missed the point by 3 orders of magnitude. Absolutely crazy, absolutely, an idea that needs to be put to death 30 years ago. And I give you the fundamental reasons, and I hope to hear from my physical layer colleagues. John has a lot of experience on the modem side and also in Wi-Fi side. Wang Tong has a tremendous experience on the base station side. On the base station side, we make the money on high performance. You achieve high performance through custom silicon. No two ways about it. Under full load, 400 megahertz, hundreds of simultaneous users, 64 antennas, 120 antennas, there is no way you're going to do it in the software and try to save it on some developer hours saved. No way. Number two, that's performance, just raw performance. Number two is power consumption. You compare the power consumption between custom ASIC, well, of course, custom ASIC nowadays includes accelerator subcores, and it's not the all ASIC full custom from the past, but it's a very sophisticated engine, but with the custom design for the application, whether it's turbo decoder or et cetera, physical layer. Power consumption, order of magnitude worse. And I forget what the third, cost, and the third one is cost. So you 3 orders of magnitude off the mark. Now, if you want to play around in an academic environment and you want to have a programmable radio, go ahead, be my guest. You can do it. You can do it with, for what I care, Raspberry Pis, but not with real base stations.
In defense of academics, I would say the proposal comes from NVIDIA, not academia.
Yes, they have a self-interest of grab at the gold mine of base station infrastructure service providers. They're not inside. They want inside, and that's they're into a market that they don't own.
200% agree. Even for the NVIDIA situation, if the mass silicon chip from them is the AI model with large language model with with the inference, that's the massive, probably the largest chunk of the silicon. Those are, today it's 8-bit. It is now going to 3-bit. Probably the latest one is 1.5-bit. So all the radio signal, you never go through 3 bits or quantization or 1-bit quantization. So, and then if you go back to the very exotic, 32-bit in the rendering machine, that's another. So it's probably add more magnitude order compared to Renado's cost and the power. So that's an exhaustive machine. So unless Nokia and Huawei are not there, some amateur will need some hardware to stack that up. That will be Raspberry Pi solution.
I wonder if John agrees on that.
Is neutral.
Well, I'm hesitant because there's this ongoing, there's a so-called XHAL splits. There's a 7.2, and where do you put the decoders and signal processing, whether it's in the DU or the RU, is a controversial subject. And of course, the more processing that moves higher up, the more to the NVIDIA style solution, and then the more that moves down to the radio unit is more to the others. And that, I think the software solution is inevitable, whether it's 5 years or 25 years is the real question on this. And so, I salute what they're trying to do. AI ran and support that. It may be a little harder to do than it looks superficially to do that, and they will run up against the equipment suppliers. Nokia and Huawei are among them. That will have maybe other interests in a more custom accelerator, with CPU type approach, because that fits better with their control and business practices. So the inevitability is there, but not, the time frame is always hard to call on this. And as you say, software-defined radio, it's like 2000 or something, the first time I think I heard about it. So that's it's a great idea. But on the other hand, I tell the young students when I start teaching them communication, I said, when I started my career, I was trying to get 5 kilobits per second over a phone line. Now you got it's something like 5 gigabits per second today is what your access speeds are to the network. So by the time you guys get to my age, it's going to be 5 petabits per second that you're going to be dealing with. So over short periods of time, it doesn't move too much, but over decades, it does move spectacularly, and things that we do in software today, we never would have dreamed we could do that 25 years ago. So but the trend is clear. It goes that direction. So.
Well, I would beg to differ. I think the trend, if the trend is such that the performance required keeps growing, and microelectronic performance keep growing, if we assume that, then the software-defined radio is always way behind. Now, if for some reason, and let's hope not, the need for performance flattens, and then software-defined radio could eventually catch up through microelectronic avances, then that's fine. But if we get to that point, we have bigger problems, like fighting 80% of our workforce. So let's not hope the requirements are plateauing. And as the trend goes like this, I don't think there is any inevitability. Quite on the contrary, the custom design relying on the latest geometry of silicon would always continue to be 3 orders of magnitude ahead. And I was surprised you were focusing on cellular solutions, because I wanted to point out to you, in the massive cost and power consumption competitive environment of Wi-Fi, if I understand correctly from the outside again, everything that makes you a winner inside the routers or the clients is custom silicon. Nobody's doing FPGAs for routers that I can tell. And for the same reason, nobody wants to pay the price, the power consumption, and the processing penalties.
That is true.
That's a good point.
Yeah.
On that, and Wi-Fi has always followed its own kind of path, and what I can say is I think it's like 90%, maybe it's 85% of the world's internet traffic flows on Wi-Fi, and the rest on cellular. But then if you look at the amount of money, I think it's 85 or 90% of the money earned is on the cellular side and not on the Wi-Fi side. So it's really hard to do that. The Wi-Fi is not yet really centrally controlled in any way. It's just this ad hoc thing, and it's got advantages for being that way. Will it become that way, or will it continue on the path that it is now? They always write the standards for Wi-Fi to try to put more and more control and capabilities for the things to talk to one another, all that. But then I don't think the Wi-Fi manufacturers use any of that stuff. I don't even think they use the multi-user MIMO. I think they just blast as fast as they can to each user and pop over to the next one on the CSMA protocol. So it's hard to say, but the customers are happy with that until the Wi-Fi is broken, and then everybody's angry, right, at that point. So
I think we probably look at one side of the whole problem, and that is the cost mainly. But the performance, I mean, for example, Wi-Fi, the spectrum utilization is far worse than what is in the cellular system. If you have the luxury of so much bandwidth and you can waste it so much, so be it. You can do dirty engineering. I'm not against Wi-Fi. I'm just saying that it is not the state of art in terms of engineering solutions. And if you want the quality of service, etc., guaranteed, low latency, and that sort of things, okay, Wi-Fi is not the solution, and probably virtualize the baseband and the RF side into SDR, etc. It is not the solution to do it. Depends on what you want. On the other hand, is the cost. When you do software-defined radio, it doesn't have to be from antenna to the amplifier to the filters, and everything has to be software-defined. You could have very agile frequency synthesizer to cover a wide band and different bandwidth. And I think that is important. If you want to develop a new RF front end, probably software-defined radio, there are already technology available that it does wideband. I know one starts from 300 kilohertz all the way to nearly 6 gigahertz bandwidth you can cover at different bandwidth. And military defense, especially US defense, is using that a lot. And so it depends what you want out of the system. I think we cannot say one solution is the best for everything. And most of the operators, the network operators, from a cellular perspective, the cost for them of the energy consumption, utilization of the spectrum, and also the cost of the upgrade of the system is very important to them.
So let me follow up with a little modesty. My comments were 100% centered around worldwide cellular networks. And in that context, I think we fully agree the advantage given by custom design is just order of magnitude ahead of anything else, and will remain so for the foreseeable future until we really have depressing trends on the traffic side. But the truth or the reality can be very, very different. You talked about, for instance, small teams, whether they are tactical or enterprise, and then the issue of top performance is not there. And maybe the issue needs to be more about programmability, adaptability, and then absolutely 100% I'm with you. Or if you are doing experimenting or you are in an educational environment and you want students to have experience with, whether it's media access or scheduling and whatnot, you want a full programmable solution, absolutely. There are many other scenarios. Cellular is one, and there are others. Absolutely.
Thanks.
Regarding the first item, I see because discussions goes in the direction about the execution of the network flow or execution of the network service, and somehow talking about end-to-end monitoring and the performance adjustment. But there is another aspect of it, like say basically networking logic of this interaction. Whether that part can be also determined dynamically, automated, generated. Yeah.
Thanks. Any response?
I think, does that mean that can the network?
Yes, the networking procedure logic, whether that can be automated.
I think it's all how you define quality of service in the network. I know that you are referring to question one.
Well, yes.
But the logic could be based on what are the parameters in your quality of service or your SLA to define. And whether AI can develop new logic, you mean new function, is that right? Or new policy?
New mechanisms for those network entities to interact with each other, to offer a particular service. Let's say there's 4 or 5 network entities. They talk to each other. Each of them may perform some tasks. And then there's a way to organize them, make them to perform the task in particular order, for example. Eventually, the service is offered to the customer. So this, let's say, the planning or orchestration of these behaviors of these network entities. So this is automated by the AI, but that's feasible part.
That could be an important offline discussion or future research topic. So how about, now it's 3:20. It's the time to finish the panel. Let's give a round of applause to our panelists and also our audience. Thanks for all you.
you.